Hi, in this video, we're going to look at how we go about simplifying exponential fractions. Now, in our previous videos, we have looked at how we go about finding prime bases, and we are now going to use this idea to simplify our fractions. Please keep in mind that the third rule for exponents tells us that when we multiply terms, we can add the exponents together as long as the bases are the same. The fourth rule of exponents tells us that when dividing, we can subtract exponents as long as the bases are the same. To better explain how we go about simplifying exponential fractions, I'd like to look at some examples. Let's make some space. Simplify the following expression: x to the power of 2x minus 1 multiplied by x to the power of 3x plus 4 all over x to the power of 5x plus 3. We have a base of x, a base of x, and a base of x. Here we are multiplying x to the power of 2x minus 1 by x to the power of 3x plus 4. So we can add these exponents. And we can say x to the power of 2x minus 1. And then we're going to add 3x plus 4. So we say plus 3x plus 4. Now remember that when you are working with fractions, we're actually dividing the numerator by the denominator. So in this case, we are dividing by x to the power of 5x plus 3. And remember that when we are dividing, we can subtract exponents. So we can say minus 5x minus 3. And now we can add like terms within these exponents. So let's write down our base of x. We have got 2x plus 3x, which is 5x, minus 5x, which cancels out, and we get 0. Then we have negative 1 plus 4, which is 3, minus 3 is also 0. So we have x to the power of 0. And we know from our rules for exponents that anything with an exponent of 0 is equal to 1. So we can say equal to 1. Let's do another example. Simplify the following expression: 3 to the power of n multiplied by 9 to the power of n plus 1 all over 27 to the power of n plus 2. Here we have a base of 3, a base of 9, and a base of 27. They are not the same. So the first thing we need to do is change our bases into prime bases. We have a prime base of 3. So we can say 3 to the power of n multiplied by. Next, let's find the prime base of 9. 9 divided by 3 gives us 3. Divided by 3 gives us 1. We can see here that 3 multiplied by 3 gives us 9. 3 multiplied by itself is 3 squared. So we can say 3 squared, put into a bracket, with our exponent of n plus 1. Now in our denominator, we have 27. We know that 3 multiplied by 3 multiplied by 3 gives us 27. 3 multiplied by itself 3 times is 3 cubed. So we can say 3 cubed in a bracket with an exponent of n plus 2. Our next step is to multiply the exponents inside the brackets by the exponents outside. Let's put in our equal sign. We have 3 to the power of n. We can leave it as it is. Now we have a base of 3. Inside our bracket, we have an exponent of 2. So we can say 2 multiplied by n, and we get 2n. 2 multiplied by 1 gives us positive 2. All over. In the denominator, we have a base of 3. Now we have an exponent of 3 inside the bracket. So let's multiply it by the exponents outside. 3 multiplied by n is 3n, and 3 multiplied by 2 is positive 6. Now we have a base of 3, a base of 3, and a base of 3, which means we can add and subtract our exponents. So let's put in our base of 3. From the first term, we have an exponent of n. We are now multiplying, so we can add our exponents. So we can say plus 2n plus 2. All over. Remember, when you consider values in the denominator, we are now dividing, which means we subtract our exponents. So we can say minus 3n minus 6. Now we can add like terms within our exponents. So we have a base of 3. We have n plus 2n, which is 3n, minus 3n, which gives us 0. Then we have 2 minus 6, which gives us negative 4. But we don't want a negative exponent. We want a positive exponent. So we know we can rewrite this as 1 over 3 to the power of positive 4. From previous experience, we know that 3 to the power of 4 is 81. And we get an answer of 1 over 81. And we have now simplified this fraction. Let's do another example. 4 to the power of x multiplied by 81 to the power of x plus 1 multiplied by 3 to the power of 2x minus 5 all over 4 to the power of x minus 2 multiplied by 9 to the power of 3x minus 1. Now our bases are not the same. So the first thing we need to do is to change all of these into prime bases. We know that 4 is 2 squared. So I can say 2 squared, put into a bracket. We have an exponent of x. In our previous example, we know that 81 is actually 3 to the power of 4. So I can say 3 to the power of 4 with an exponent of x plus 1 multiplied by 3. It's already a prime base, so we can leave it as it is, with an exponent of 2x minus 5 all over 4. Once again, it's 2 squared, 2 squared, exponent of x minus 2 multiplied by 9. We know that 9 is 3 squared. I can say 3 squared with an exponent of 3x minus 1. Now I need to expand these brackets. So let's multiply the exponents inside the brackets by the exponents outside. I have a base of 2. 2 multiplied by x gives me 2x multiplied by a base of 3. Now I have 4 multiplied by x, which is 4x. Then I have 4 multiplied by 1, gives me 4, multiplied by 3 with an exponent of 2x minus 5 all over. Got a base of 2. Now we need to multiply 2 by x minus 2, and we get 2x minus 4 multiplied by base of 3, and then we multiply the exponent of 2 by 3x minus 1. 2 multiplied by 3 is 6, so I get 6x. 2 multiplied by negative 1 is negative 2. Now I have bases of 2 and bases of 3. So let's start with our base 2. So I'm going to say 2. I have an exponent of 2x, so I can say 2x divided by 2 with an exponent of 2x minus 4. So we're going to subtract 2x minus 4. So we say minus 2x minus negative 4 becomes plus 4. Multiply by base 3. Let's put in our 3 over here. We have 4x plus 4. I can say 4x plus 4. Then we're multiplying by 3 to the power of 2x minus 5. So we can add these exponents, plus 2x minus 5. Then we're dividing by 3 to the power of 6x minus 2. So we're going to subtract these exponents. And we say minus 6x minus negative 2, which becomes plus 2. I'm going to write it over here. Now we can add like terms within the exponents. So I have a base of 2. 2x minus 2x is 0, and I'm left with an exponent of 4. Multiplied by the base of 3. Then we have 4x plus 2x, which is 6x, minus 6x, which is 0. 4 minus 5 is negative 1, plus 2 gives us positive 1. And now we have 2 to the power of 4 multiplied by 3 to the power of 1. 2 to the power of 4 is 16, and 3 to the power of 1 is simply 3. Now let's multiply 16 by 3, and we get an answer of 48. Let's do another one. 3 to the power of n plus 1 multiplied by 4 to the power of n minus 1 all over 6 to the power of n minus 1 multiplied by 2 to the power of n plus 1. Our bases are not the same. So let's start by finding our prime bases. We've got 3, which is a prime. I can say 3 to the power of n plus 1 multiplied by 4, which we know is 2 squared. So I can say 2 squared to the power of n minus 1 all over 6 to the power of n minus 1. Let's find the prime bases of 6. 6 divided by 2 is 3, and divided by 3 is 1. So the prime bases of 6 are 2 and 3. So I can say 2 multiplied by 3 with an exponent of n minus 1 multiplied by 2, which is already a prime, to the power of n plus 1. Now we can multiply the exponents in the brackets by the exponents outside. So we're going to have 3 to the power of n plus 1, we can leave it as it is, multiplied by a base of 2. We now have an exponent of 2 multiplied by n minus 1, and we have 2n minus 2 all over. In this bracket, we have 2 and we have 3. And remember that when we have a simple number, it has an exponent of 1. And now we have to multiply the exponents of 1 by the n minus 1 outside of the bracket. So we have a base of 2. 1 multiplied by n minus 1 is simply n minus 1, multiplied by the base of 3 from over here, and an exponent again of n minus 1. Finally, we can multiply by 2 to the power of n plus 1. Now we have bases of 3 and bases of 2. So let's start with 3. I can say base 3 over here. We have 3 to the n plus 1, so n plus 1, over 3 to the n minus 1. We are dividing, so we're going to subtract n minus 1. Say minus n minus negative 1, multiplied by base of 2. Here we have 2n minus 2, say 2n minus 2, divided by 2 to the n minus 1, so minus n minus negative 1, and we're also dividing by n plus 1, so we say minus n minus 1. Once again, let's add like terms within the exponents. So I have a base of 3, n minus n is 0, 1 plus 1 is 2, multiplied by the base of 2. Now I have 2n minus n, which is n, minus n again, which is 0. Then we have negative 2 plus 1, which is negative 1, minus 1, which gives me negative 2 again. 3 squared we know is 9. 2 to the negative 2. 2 squared is 4. Our exponent is negative. So this becomes 1 over 4. Multiply these together and we get 9 over 4. And this is our final answer. Please have a look at some examples in this section before continuing with these videos.